So hi everyone, how are you guys doing? So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this particular channel of Unacademy, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 12 students, and this is to help them quickly revise all the key concepts of their syllabus, okay, before their upcoming JEE. All right, so today we'll be talking about electrostatics, and this is a quick review of electrostatics part 1. Now, before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. So, my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE exams, both mains and advanced. So, for 7 years, I've taught in offline setups, and for past 1 year, I've been teaching in the offline online setups. Okay, so as a student, I myself was All India rank 447 and All India rank 192 in the two stages of the ITJ exams that I took. Now I also qualified at the NTC Stage 2 examination and the NSEP. I was in top 1% there also, and I've already coached many students to top ranks in the ITJ exams in my offline years of experience. And now my hope is to continue guiding you guys to your top ranks and dream colleges on this online platform. All right. So students who are worried about their preparation needs and don't know, where to get access to good quality education. So you guys have a wonderful option now. You guys can opt for the Unacademy subscription. Now, this subscription will give you benefits like live classes where you get to interact with your educators on a regular basis. You also have live polls and leaderboards in these classrooms. Then you have test series and analysis, very important for a competitive exam like IIT JEE. So, hello Raj, hi AP, how are you guys doing? And of course, you have live doubt clearing sessions. So, for all Unacademy Plus courses, every fourth session is a dedicated live doubt clearing session. So, after every 3 teaching sessions, you have one session which is entirely dedicated to your doubts. Okay, so where students may ask any doubts about their concepts that they did not follow or any difficulty that they are having in problem solving. Now, along with all these benefits, of course, you are also getting the chance to study from the best educators all across the country from the comfort and safety of your home. So I think that's a huge advantage, and that's a wonderful opportunity that most students should not miss out on. Now, how do you avail these benefits, and how do you make sure that you are getting access to the best possible education in this time? So you can the first step involves for you to install the Unacademy app. The moment you do that, you will unlock for yourself a lot of free features like free courses. So there are free courses running on the Unacademy app in which you can enroll simply after installing the app. Then you can attend special classes. Okay, so there are special classes which are free for all. So almost all educators take these special classes which anybody can attend as long as they have downloaded and installed the app. And then you have quizzes, so you can take part in quizzes also. So all these features are absolutely free. No subscription is required for all these features. Okay, all you need to do is install the Unacademy app and you'll be asked an invite code. So there you can enter this code RD Live. So that is my code, and you will get access to all the free features of the Unacademy app. So that already gets your preparation started. Okay, hello Amod Kumar, how are you? So once your preparation is started and once you get a flavor of how your education is going to be with the Unacademy subscription, and finally when you decide to take things to the next level, then you need to buy the Unacademy Plus subscription. And these are the steps that you can follow to do that. You go to the plus section of the app, select your goal as IITJ, and click on the get subscription button. Now the moment you do that, you will be redirected to the payment page where you will find a box that will say, do you have a code? So that is where you can enter this code RD Live. So this code will give you a 10% off on all your subscription fees. Now, whether you choose Plus subscription or you choose the Iconic subscription, the fees of the following subscriptions are as follows. And finally, when you click on proceed to pay, you will also realize you're given an option of choosing various no-cost EMI plans where these payments can also be broken into smaller amounts, okay, so that you don't feel the pinch of this amount. Next, the students who don't know what the Iconic subscription is, so that is a relatively new offering by Unacademy. This is something that will take your IIT JEE preparation to the next level by allotting you personal coaches. So from our team of experts, you will be allotted personal coaches who will personally mentor you and guide you throughout your IIT JEE journey. And along with all the plus benefits, you also get to attend IIT JEE workshops, receive expert guidelines from time to time, get a study planner, which is very important, I know. I know for a lot of students, and regular test analysis sessions. So with all these additional features, you will power through your IIT journey. Now, students who have just entered class 11th and are worried about how to go about their preparations. So you don't need to worry. Now Unacademy is providing you combo subscriptions. These are single one-stop solution to all your study needs. So this kind of combo subscription provides you a chance to prepare for your CBSE class 11, CBSE class 12, and hence your boards, your IIT JEE Mains, your IIT JEE Advanced. So everything is taken care of in these combo subscriptions. So there are 4 combos that you can choose from. The first combo offers you the iconic subscription for IIT JEE and plus subscription for 11th and 12th. This subscription starts at around 4,600 a month. The second combo offers you the iconic for all 3, and this combo starts at 5,500 a month. Third combo offers you plus for all 3. This combo starts at roughly 3,000. The final combo offers you plus for IIT JEE and iconic subscription for 11th and 12th, and this combo starts at 3,900 a month. Again, you can choose a subscription that suits your study needs and then leave all your study worries behind. Now, students who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. So that'll make sure that you're receiving all the timely notifications of every lecture and session happening here, that you're not missing out on any of the important content being provided here. All right, so with all that information out of the way, let's get started with the quick review. This is quick review part 1 of electrostatics. So first, we need to understand what electrostatics is. So we realize that the study of electromagnetism is usually divided into 2 parts. So electrostatics and electrodynamics. Okay, now why do we do that? That is because the behavior of charges is different when they are at rest, and behavior of charges is different when they are moving. So electro word refers to charges, and their study is divided into 2 parts. When electrostatics, which essentially deals with charges at rest, and all behaviors of interaction and interactions of charges kept at rest is studied under this. Then you have electrodynamics, which is the study of moving charges. Okay, so turns out charges have different behaviors when they are at rest and different behavior when they are moving. That is why we study it in 2 parts. All right. So first, let's also talk about charges. So what exactly is a charge? So this is the best possible definition that you'll get for a charge. A charge is a fundamental property of matter responsible for all electromagnetic phenomena. Okay, so what do I mean by that? So when I say the word fundamental, when I use the word fundamental, so that means it is an inherent property of matter. Okay, next, it is a property of matter. So that means, by definition, matter is something that has mass. So something that has mass can only possess charge. Please remember that. Something that does not have mass can never have a charge. Okay, now this is the fundamental property or the inherent property that is responsible for all electromagnetic phenomena. What are electromagnetic phenomena? Phenomena related to electric fields and magnetic fields. Okay, so all the influences of these fields, creation of these fields. So these are electromagnetic phenomena. Now, only matter can have charge. So as I said, there can be mass without charge, but there can never be charge without mass. Okay, so you need to remember that. Now, having a charge gives a body to create and experience electric and magnetic fields and forces. Okay, so that's our basic premise of definition of a charge. Next, let's talk quickly about the properties of charges. So first, we realize that charges are of 2 types. Again, these are all experimental results. The initial theory was based on a lot of experiments that happened, and finally, we have figured out these properties over years of experiments. Okay. So first, charges are of 2 types. Then like charges repel, unlike charges attract. Okay, both charges have an effect that tend to neutralize each other. And that is why they were given positive and negative sign, because positive and negative signs tend to cancel each other out. Okay. So, and by convention, the charge on a proton was called as positive and charge on an electron was called negative. So there's no special reason why, an electron's charge is negative and a proton's charge is positive. Okay, it is just a matter of convention. When people decided for the first time, they said, okay, let's call the charge on the electron as negative. If they had decided to call the charge on the electron as positive, then you would have been studied the other way around. Okay, you would have said that electrons are positively charged and protons are negatively charged, and wouldn't have really mattered in all your study. Okay, who's positive, who's negative doesn't really matter. You have to assign one name to one, and this is what was decided by convention. Next, what you realize is that charges are scalar. Of course, they have no directional association to the direction of any. There is no direction associated of any kinds with charges. The SI unit of charges is coulomb, but the practical unit is microcoulomb. 1 coulomb practically is a huge, huge charge. Practically, the charges that exist, you will realize exist in microcoulombs only. Now, they are scalars, so they can add and subtract like normal numbers. So if you have a plus 2 coulomb charge and you keep with it a minus 1 coulomb charge, so the net charge would be simply just sum of these two. Okay, so plus 1 coulomb. Next is the charge is conserved. Now, please note that this is very, very important. The net charge of an isolated system is always conserved. When I say charge is conserved, we always talk about the net charge of any system being conserved. Individually, charges can, however, change in energy mass conversions. So please note, I think since this is a revision class, so most of you would know that matter can be converted into energy and energy can be converted into matter, right? Matter and energy are interconvertible. Correct? Now, you will realize one thing, that matter can have charge because it has mass, can have charge. How about energy? Can never have charge. So please note, very, very important. I had told you that something that does not have mass can never have a charge. So energy, of course, doesn't have mass, so doesn't cannot ever have a charge. So what happens when suppose an electron gets converted into energy? What happens to its charge? Does the charge conservation get violated? No. The charge conservation is one of the fundamental principles of nature that we see having no violations. Okay, so Sanjay Sharma says, "Hi, sir. Sir, did you see my comment?" So when mass, yes, 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 I did, Sanjay. And thank you so much for your kind words. Okay. So when mass having charge changes into energy, will there still be charge? Yes, that is what I was coming to, Suraj. So what happens is suppose you have an electron, you have an electron. Turns out an electron does not directly get converted into energy. Okay. So all energy mass transfers, uh, let's add a page and just tell you a bit about that. Turns out all energy mass conversions happen in pairs. Okay, you need to know that all matter and energy conversions happen in pairs. So how do you think the electron was created in the first place? We believe that when Big Bang happened, there was a lot of energy that was released, and energy at times would convert into matter. Okay, so there was energy that got created in a Big Bang, and that energy created matter. Okay, matter was created from this energy. So when matter, when energy, let's say, wanted to create an electron, so it turns out it produces two particles because all conversions happen in pairs. So when energy converts to matter, it produces two particles, which are electron and something called positron. Okay. So please remember that that is very, very important. Now this is called pair production. This thing is called pair production. So whenever matter is produced from energy, whenever matter is created from energy, it is always created in pairs. So you have always two entities. Okay, whenever energy is converted into matter, energy, whenever it goes into matter, it creates two particles always, which are called, one particle is called particle, plus you have something which is called antiparticle. So that is how all energy matter transformations take place. But sir, one quick question: matter was concentrated at singularity before Big Bang. Isn't this black hole? And is, yes, of course, Sanjay. I am seeing this chart. I am seeing this chart. Concentrated. Yes, antimatter. Of course, antimatter exists. Hmm. So if a lot of matter was concentrated, why did Big Bang happen? Okay, so it is wrong to assume that there was a lot of mass concentrated at the singularity point. We do not really know what exactly went down in Big Bang. We know that Big Bang was some sort of explosion which released a lot of energy, and then eventually that energy got converted into matter. All matter was created by energy released in the Big Bang. We don't know what was before Big Bang. Nobody knows what was before Big Bang. Okay, so that is one area where we do not have much knowledge. We do not know before Big Bang what must the universe or the situation would have been. Okay, we can only postulate, but concentration of antimatter is low, and or is it high? Because we do not feel it. So the thing is, lucky for you, what happens is, so as I said, whenever energy gets converted into matter, whenever energy creates matter, it always produces two particles. This is called pair production. A particle is created and an antiparticle is created. So it turns out, what are the relations between particle and antiparticle? You realize there are some basic conservation laws of physics. Okay, conservation laws of physics which never get violated. So conservation laws that never get violated. So these are laws are as follows. So A, momentum conservation. This is one of the most fundamental laws of nature. This will never get violated. Then, of course, you have conservation of charge. And then you have angular momentum conservation. And you have a lot, some more laws which we won't talk about. Okay, there is something called conservation of hypercharge. Then there is of course conservation of energy and mass. Okay, so those we won't list, but these are some of the conservation laws of nature that never get violated. So the pair production enables that all these laws hold true. Pair production ensures that all these laws hold true. Okay. So, for example, let me tell you what is happening. What is happening? So, when you have an electron and you have a positron, so turns out, if I compare electron and a electron, and let's compare positron, which is the antiparticle of electron. Okay, so has mass me equals 1.9.1 into 10 to the power minus 31 kg. Turns out this has identical mass. Has mass equal to 9.1 into 10 to the power minus 31 kg. Exactly identical mass, exactly identical size. Yes. Then charge. The charge here is minus 1.6 into 10 to the power minus 19 coulomb. And a charge here is plus 1.6 into 10 to the power minus 19 coulomb. So that makes sure that before matter got created, energy of course had a net zero charge. So even after energy gets converted into matter, the total charge remains the same. Now obviously you will realize, if the total momentum was zero for energy initially, then the electron and positron will fly off in opposite directions to ensure momentum conservation also. And then you have spin angular momentum. So if this guy has spin plus minus halves, which is related to its spin angular momentum, this guy will have spins which will be opposite, minus plus half. Okay, so this will make sure of angular momentum conservation also. Okay, so that is what is happening in all the energy matter transformations. Okay, so there is pair production. So that pair production ensures that your net charge does not change. Please note, we always talk about net charge, net momentum, net angular momentum. Those are always conserved. Okay. Hmm. So I told you na, the spin causes spin angular momentum. Okay, have you studied about spin of an electron? So every electron is spinning about its own axis. So which gives it an angular momentum, which is called spin angular momentum. Okay. Now the point is, hi Rishi, how are you? Now the point is, so this is one way. One way we are sure, okay, when energy is getting transferred into matter, then all the conservation laws are holding up. अब इस वाले चैनल पे आपकी जगह से कोई और पढ़ाएगा क्या, पता नहीं यार, पता नहीं मुझे, ठीक है। अभी दूसरा चीज क्या होता है, दूसरा चीज क्या होता है कि when matter gets transferred to energy. Okay, now let's talk about the other transformation, matter converting to energy. Then again, you have something called pair annihilation. Okay, pair annihilation. Okay, they get destroyed, matter gets destroyed in pairs also. Okay. Okay, so what happens is a particle and an antiparticle, particle and an antiparticle will collide and get converted into energy. That is how matter gets transferred into energy. There are collisions happening between. Okay, okay. So okay, I don't know. So we had a certain contract. Okay, the entire team had a certain contract for a certain time duration, and that contract is getting over. So we don't know if what will happen in the future. Okay, so that is what I think Shivam is referring to. Okay. Hmm. So again, an electron by itself cannot get transformed into energy. It's actually a collision of electron and a positron. So this is the symbol of positron, by the way. When these two collide, they convert into energy. So you realize in both ways, whether matter is getting transferred into energy or energy is getting transferred into matter, the net momentum, the net charge, the net angular momentum, they always remain conserved. Okay. Please note net. Okay. So there is a question that I usually like to ask, that suppose, and this can be a good question for conceptual question for your advance. Okay, so suppose today observable universe or universe has, hypothetically, has plus 3 coulomb and minus 3 coulomb charges. Then in a million years, in a million years. Okay, now so this is the interesting part of discussion. So it's Sanjay asked. So how is it that we don't see antimatter? What is antimatter actually? What do you think is antimatter? So let me just tell you about that. So for every particle there is an antiparticle. Okay, for a proton there is an antiproton, for a neutron there is an antineutron, and so on. So for every particle there is an antiparticle. But we believe that initially, right after Big Bang, what happened was that energy converted into mass, created, let's say, electron and positron. Now sometimes these electrons and positrons collided again, got converted into energy. Sometimes they managed to drift apart. Okay. So thankfully for you, most of the particles and antiparticles were able to drift apart. So they were able to drift apart, and that is why they remained as matter. Yes. Okay. And that is how your universe got created. So we believe that, suppose here you have hydrogen, okay, where you have a proton here and you have an electron revolving around it, correct? So somewhere in this universe, because all energy matter conversions would have happened in pairs, so somewhere you would have had an anti-proton and a positron revolving around it. Okay, and that would be called the antimatter of hydrogen. Okay, but luckily enough, so you said if they merge, then everything will what causes pair production and pair annihilation. So we don't know for sure. We don't know for sure. So we are not very sure what exactly leads to this. Yes, everything would have ended if these two ever collide. If these two ever collide, then they would destroy each other, create energy once more. Okay. So we don't know what exactly triggers this conversion. Sometimes it just happens. Okay. So we just know that. Okay. Now, thankfully, all this must have drifted apart, and that is why you have this universe where you have all the matter, and then you probably would have an entire set of universe which would be made up of antimatter everywhere. All right. So that is what we believe. That is what we believe. That because the net charge has to be conserved. So if there was no assuming there was no net charge before the Big Bang, so right now also in the net universe, the net charge must be zero. So for every proton that I see, there must be one antiproton, and for every electron there must be one positron, and so on. Okay, so that is a very interesting thing. Again, so this can be a trick question. So if today we realize that the universe has plus 3 coulomb of positive charge and minus 3 coulomb of negative charge, then in a million years, option A says there must be there must be plus 3 coulomb and minus 3 coulomb charge. Option B, let's say there may be plus 4 coulomb and minus 5 coulomb charge. Option C says there may be minus 2 coulomb and plus 2 coulomb charge. And option D says there may be minus 5 coulomb and plus 5 coulomb charge. So which of the options is correct? Yes, theoretically there can be an anti-U, Suraj, which is made up of every particle reversed. Every particle with its antiparticle. Okay. So if you are made of carbohydrates, hydrogen, carbon, oxygen, so all anti-hydrogen, anti-carbon, and anti-oxygen making BCD. Okay, no, B is not correct. B is not correct. Only C and D are correct, Baba. Why B? B says plus 4 coulomb and minus 5. That means the net charge is minus 1. So B, C, D is not correct. So our antiparticle is a girl. That's maybe, I don't know. Let's hope not, because once you meet them, then you will destroy each other, right? Let's hope not, right? If you meet your antiparticle, you know both you guys destroy each other. So, Sanjay, let's hope that is not the case. You don't want to be destroyed or destroy somebody else. Okay. Yes. So again. So please remember, whenever we talk about conservation of charge, it is always about conservation of net charge. Okay. So that is very important. Uh, Again, as I said, this could lead to a very good question. Okay, which would confuse most of the people who would think that conservation of charge means individually the charges are conserved. Individually, charges are not conserved because there may be energy mass conversions happening. You don't know. Okay, so individually, maybe the net charge would increase, the net charge would decrease. But individual charges may increase or individual charges may both decrease, but the net charge will always remain the same. Right. So next property of charges is that charge is always quantized. So practically, in the universe that we are dealing with, so we know that all matter is made up of atoms. Atoms are made up of nuclei and electrons. Now, inside the nuclei, the charges are very strongly bound, so you cannot take them out. And practically all charge transfers happen by transfer of electrons. And electrons have a fixed amount of charge, which is this. So any charge that you give a body is either by taking away electrons or giving it extra electrons. So whenever we give charges to things, we either take away electrons or we give them additional electrons. So all charge that will appear in this on any body would be an integer multiple of the charge of an electron. So please remember that. So though there are particles like quarks that carry charges of e by 3 and 2e by 3, they do not exist freely in nature. So we have realized that turns out protons and neutrons are made up of quarks. Okay, turns out you will realize protons are made up of 3 quarks and neutrons are also made up of 3 quarks. So they are also have particles which constitute them. Okay, sir, I can't distinguish whether your English is British or American. Okay, I'm not sure. I think it's more Indian, right? I don't know. It's neither, I guess. It's neither, right? So it's neither British or nor American. It's probably the Indianized version of English. Middle East. Wow. ये सब मत बोलो भाई मरवाओगे. Anyhow. So it turns out uh, when in particle accelerators you collide two protons, they disintegrate into quarks. However, those quarks recombine immediately, almost immediately into protons. In any case, so once, first of all, practically it is almost impossible for you to pull out a proton from a nucleus, and then it is almost practically again impossible for you to break protons into quarks. Okay, so that is why practically I do not bother about quarks which can have e by 3 and 2 e by 3 kind of charges. So it turns out that happens. There are 6 kind of quarks, by the way. In fact, just like how Flash was made. कॉमिक हो ना क्यों नहीं all right. Next, charges are relativistically invariant. So this is another interesting property of charges. So mass, again being a fundamental property of matter, depends on velocity. Depends on your velocity, and you see those effects when that velocity is close to the close to your velocity of light, right? But thankfully, charges do not exhibit that. Okay, so that is a very important property of charges. So we know two most fundamental properties of matter: charge and mass, right? Mass depends on the speed. You know that it changes with speed with the equation m equals m naught over root of 1 minus v by c whole square, correct? And this was Einstein's equation. But turns out charge is independent of your velocity. Okay, it does not change with velocity. Again, you can see the proof of that because in different atoms, you realize all the electrons are moving, and they're moving with different speeds. Okay, E equals mc square is something else. E equals mc square is for energy mass conversions. Energy mass conversions. So when E amount of energy gets converted into mass, it will create mass m, which would be E by c square. Or when m mass gets converted into energy, then it will create mc square amount of energy. So E equals mc square is for energy mass conversions. Okay. So what if two things move at 0.9 c in opposite directions with respect to ground? So what about that? What about that? So yes, theoretically that can happen. Two things can move with speeds of 0.9 c in opposite directions. So what about that? What is it that you are trying to ask? Okay, so E equals mc square is something different, by the way. Einstein also gave you this. Turns out your mass depends on your velocity. Turns out not only your mass, 1.8 c with respect to one another. No, that doesn't happen. That doesn't happen. You will realize not only mass depends on your velocity, but turns out length and even time depends on your velocities. Okay, again, for that you'll have to go into relativistic physics, which we don't have the time for. Okay, so turns out the time will slow down for both and the lengths will contract. So if for a ground observer, these guys are moving with 0.9 c each. Now these two will not see each other moving with 0.9 c. Okay, trust me. These two, when this guy looks at this guy, it will see a different speed, because when it sees the distance traveled is reduced for this guy. In 1 second, it doesn't see the relative distance becoming 1.8 c. No, it is less. And time also changes, so it will never see relative speed also greater than c. Don't worry. Again, we will have to get into relativity for that, which is not the aim for today's discussion. Okay, we will have that discussion maybe sometime later. Okay, that's an interesting discussion after your exam. Maybe we can have a session where we can discuss all this fun stuff. Yeah, I can have special sessions on relativity. That will be fun. Anyhow, so let's move forward our discussion to Coulomb's law now. Okay, so we've already realized the properties of charges. Next, we'll talk about Coulomb's law. What is Coulomb's law? Coulomb's law gives us the mathematical relation to find the force acting between two charges. Now, experimentally, Coulomb found, please note experimentally Coulomb found that the force between two charges is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. So he gave this equation: F equals K Q1 Q2 over R squared. Turns out that K constant depends on the medium and is usually K is represented as 1 over 4 pi epsilon. That's that's the usual representation, where epsilon is called the permittivity of medium. Okay. So for vacuum, epsilon is represented as epsilon naught, and the value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9 SI units, where epsilon naught is called the permittivity of free space. Again, you can check the dimensions of this also. A lot of questions are asked on dimensions of epsilon naught. Okay, so do practice that. Next, some really important points about Coulomb's law, which you guys don't realize. So one, of course, it is an experimental result. Then it is defined only for point charges. So please note that Coulomb's law is only defined for point charges. You do not apply Coulomb's law between big objects. So you will realize, in fact, if you have an infinite rod and a point charge kept at the separation d. I hope you remember. So this has a small charge q and this has a charge density of plus lambda. The repulsion between them will not be infinite, है ना? ये तो इस पे रॉड पे वरना infinite charge है, infinite length का रॉड है, तो इसमें Coulomb's law नहीं लगाओगे आप. Okay, you cannot apply Coulomb's law between an extended charge and a point charge or two extended charges. Correct? It is defined only for point charges. Please remember this. Very important. A lot of people do not realize this. Next, the electrostatic force depends on the medium present between the two charges and it obeys Newton's third law. Now, you will know one thing, that force between two moving charges does not obey Newton's third law. By the way, that is another interesting fact that you might want to know. The net force between moving charges does not obey Newton's third law. So if one moving charge is applying a force of F1 on another moving charge, then the second moving charge does not apply the force minus F1 on the first moving charge. Turns out that is a very strange thing. Again, that is not something in your syllabus, but still I just wanted you to know about this. Okay, a fact that you need to know. As far as charges at rest are concerned, the forces between charges at rest obey Newton's third law. Okay. Between moving charges, they do not. That is why this is important. You cannot assume that Newton's third law is a default thing. It is always true. No, it is not. You will see a violation of Newton's third law in a lot of situations. Hi Rajesh, how are you? Now we'll move on to the vector form of the Coulomb's law. So vectorially, this can be written like this. So force on 2 due to 1 is given as 1 over 4 pi epsilon naught q1 q2 over r21 whole cube into unit vector of this. Okay, so this should be square. We are using unit vector here, then this would be square. Okay, we are not using unit vector, so that's fine. Again, so remember this is the vector form of Coulomb's law. Okay, where R21 is the relative vector or position vector of 2 with respect to 1. Okay, so again, most of you would be familiar with this. Now, why don't we practice with the question? Okay, so let's have some practice with the theory that we have already covered. So here is a question. There are 3 point charges of plus q each, which are kept at the vertices of an equilateral triangle of side A. You have to find the value of capital Q for which the system will be in a state of equilibrium. For which the system is in a state of equilibrium. Okay, so try and answer this quickly. Quickly. I hope the question is clear to all. Okay. So you guys try that still, then I will help myself with some water. Okay. Again, this is a very standard typical problem to be asked from electrostatics. So definitely try this and give me an answer. Okay, so who all are trying, let me know. Those who are trying can let me know so that I know who I am waiting for. Okay. Let's see. Hurry up. Okay, any answers? No. Nobody. Hmm. सारी मेहनत मेरे से करवा लो, खुद कुछ प्रैक्टिस मत करना ना. ठीक है, चलो देखते हैं. So if I think about this, so from symmetry, what I can say is that the charge Q experiences a force here and experiences a force here and experiences a force here. Can I say capital Q must always be in equilibrium? Doesn't matter even if it is a positive charge or a negative charge. Capital Q will always be in an equilibrium. Even if it is a negative charge, it would have experienced forces like this. All the forces would have been equal by symmetry. Okay, so I don't have to bother about the capital Q's equilibrium as long as it is kept at the centroid. Okay. Next, how about the forces experienced by the other charges? Okay. So let's talk about this charge, for instance. So this will feel a force due to this. This will feel a force due to this. So the resultant would be along this direction. So to counter this, you need a force which should be attractive in nature, like this. Okay. And if I can make sure that for one it is getting balanced by symmetry, it will get balanced for the rest also. Okay. All I need to do is that I have to balance this F with this F. Okay. So let's calculate the values of these F's. Okay. So what is the value of my F? I know this F1 and this is F2, let's say, and this angle would be 30 and 30. So I know F1 equals F2 equals KQ square over A square. And I can also say F would be equal to 2 F1 cos of 30, correct? So turns out F is equal to 2KQ square over A square into root 3 by 2. Okay, so I found the value of F. Now I want to find the value of F dash. So I know what is this height. This is 2h by 3. Okay, where h is the height. So this distance, let's call it x. X is equal to 2h by 3, which can also be written as 2 by 3 into the height would be a sine 60. Okay, so a by root 3. Now I also know f dash. F dash would be k q over x square. Correct. Now for equilibrium, I want F equals F dash. Okay. Again, if here the Q has to be negative. Q has to be negative. Okay. I want F plus F dash equals 0. Okay. So that will give me 2k cubed square. Okay. So for sake of simplicity, let's keep writing it positive only. And then you have kq square over a square, kq square over a square into 3 2 should be equal to k 2 over x square, and x was a square, and from here you will get these cancelled, and what you realize is that q should be equal to minus q over root 3. If you can place that charge on the centroid of the triangle, then the system will remain in equilibrium. Okay, so that is the answer, and that is how you would have gone about solving this. Yeah, I hope this is clear to all. All right, next let's try one more question. Again, a very typical question that is very frequently asked. Okay, so you've been told two charges of 1 coulomb, 1 microcoulomb, and 4 microcoulomb are placed at a distance of 10 meter apart. Where should a third charge be placed so that such that the net force on this charge due to both these charges is 0? So try and figure this out. This should be easy. हाँ भाई, ये तो आसान है. So try this, think about this, and at least give me an answer to this. सोचो थोड़ा सा, सिंपल है, ये स्टैंडर्ड है, बहुत ही स्टैंडर्ड क्वेश्चन है. दिस इज अ वेरी वेरी स्टैंडर्ड क्वेश्चन. Okay, so AP says 20 by 3 meters from charge number 1. Okay, let's see if that is correct. So all right. So Suraj says 3.33. Yeah, I think 3.33 is correct. 20 by 3 from charge 2. It will be AP. 20 by 3 from charge 2 will be the correct answer. Okay. So let's say you have one charge here. Okay. And you have another charge here, and this is separated by a distance of, okay, so let's say that this charge lies at a distance of, this is plus 1 microcoulomb and this is plus 4 microcoulomb, and the third charge is getting placed here, somewhere here, which is a distance x here, and this is 10 minus x. Correct. So for equilibrium, okay, so for equilibrium of this charge, I can say for equilibrium of the third charge, doesn't matter what kind of charge I've put, even if it is a positive charge or a negative charge, doesn't really matter. What I realize is that k into 1 mu into q, let's assume some q charge has been kept, over x square should be equal to k into 4 micro q over 10 minus x whole square. Okay, so you realize this and this and this will get cancelled, and what you realize is that 2x equals 10 minus x, so x is 10 by 3, is in fact 3. So that is correct. Okay, so 3.33 meters from charge of 1 microcoulomb, and 20 by 3 from the other charge. 10 by 3 from one charge and 20 by 3 from the other charge. All right. Next, we'll talk about electric fields then. What are electric fields? So, to understand the mechanism of action of a force from a distance, we introduce the concept of electric field. So when we wanted to explain how the two charges are able to apply force on each other from a distance, so we got up with the idea of electric fields. So now we believe that every charge creates an electric field in the entire region surrounding it, and it is this electric field that interacts with the other charges, and it is responsible for application of forces on the different charges. Okay, now since I know one charge kept here and one charge kept here are interacting through each other's fields. Okay, so obviously the effect of any field is to apply force. So since the effect of any field is to apply force, the way to measure the strength of electric field would be again to measure the force. Okay, but however, you need to standardize that. So we measure the force applied per unit charge by a field. Okay, to measure the strength of the field. Electric field at any point in space is defined as the ratio of electrostatic force on a test charge placed at that point to the charge of the test charge. Okay. So if somebody asks me what is the electric field strength here, so I'll bring a Q charge here, bring it here. It will, let's say it feels a force F. Then I'll say the electric field here is defined as F over Q. Now you realize F is a vector quantity and Q is a scalar. So of course E is a vector quantity. Electric field is a vector quantity. Electric field turns out, though was introduced to explain the mechanism of action of electrostatic force, turns out is a real physical entity. Okay. So now we know that electric fields, magnetic fields, all your gravitational fields, they are not just mathematical entities, they are real physical quantities. In fact, and all charges interact through these fields, and electric fields follow principle of superposition. Okay. Next, let's talk a little bit more about fields. Turns out fields are okay. So electric fields are described by mathematical vector functions as a function of position in space. Okay, so usually you have electric field as a function of position. So x, y, z coordinates. That is how you define the electric field in space. Okay. Next, this function defines E in entire space. So usually the fields extend from any point to infinity. Okay, so in an infinite region, these fields extend. So with an electric field function, you can define it for any point in space, in the entire space. Now, electric fields turns out propagate with the speed of light. This is very interesting. Now, electric fields also have energy and momentum associated with them. And a test charge used to measure the fields is usually kept very small. And why is that? So that it does not alter the field acting on it. Okay. So you realize what can happen is that you have, let's say you have two charges kept here. Okay, like this. And if I brought let's say this was a plus Q charge and this was a minus Q charge. So I have a dipole kind of situation. And suppose I brought a positive Q charge here. And suppose if this was a very big charge, what would that have done is that it would have repelled this one, attracted this one, probably caused this dipole to rotate, even if the dipole was fixed. Okay, and the moment it rotates, the electric field changes. So if this charge is too big, it can alter the original configuration which is creating the field. That is why the test charge is usually kept very small, so that it does not disturb the original field creating charge configuration. Okay. Now again. So I told you that all fields propagate with the speed of light. So turns out there is a lag between you bringing two charges together and the force being experienced. So suppose if I told you that you have your sun and you have your earth. Suppose I suddenly give both these guys positive charges. Okay. So suddenly if I implanted positive charges on both, you realize the force of repulsion will not start. Okay, so anybody on earth will not start, the earth will not start experiencing the force of repulsion due to sun's charge for the next 8 minutes. You know, light travels from sun to earth in 8 minutes. So for 8 minutes, it will take 8 minutes for the field of sun to reach earth, and for the next 8 minutes, earth would not have felt any repulsion. Same goes for the sun. The field of earth would have again taken 8 minutes 8 minutes to reach sun, and hence sun also would not have felt any repulsion due to the earth. Okay, so even if suddenly I would have given sun and earth charges, the repulsion would have started acting on both of them after 8 minutes, okay, which is roughly the time taken by light to travel from sun to earth. Okay, so that is a very, very interesting thing. Okay, and that is what makes the idea of electric fields even more important. Okay, because it is the fields that are causing the forces to be exerted and not the charges themselves. Okay. Next, we'll talk about graphical representation of electric fields. So, electric field can be represented graphically by with the help of field lines. So, there were a lot of theories and a lot of propositions. Finally, we represent electric fields with the help of electric field lines. Now, what are electric field lines? So, electric field lines are imaginary. Electric field is not imaginary, but field lines are imaginary. Please remember that. So, these are imaginary lines drawn in such a way that tangent to any point on the line tells you the direction of E vector. Okay. So, or I can also say alternately mention it like that. That these are imaginary lines drawn such that the tangent at to the field line at any point shows you the direction of electrostatic force on a positive charge. Okay. Again, one and the same thing. Okay. Again, when we are defining electric field, then by convention it is taken as force on positive charge. On positive charge. Okay, because you realize if you had electric field like this, now on a positive charge, the force would act here, and on a negative charge, the force would act here. So what direction of field to be chosen from? By convention, we choose the direction of force experienced by positive charges. Okay, and that was how we defined the direction of electric. Properties of electric field lines: these are smooth, continuous curves which extend from infinity unless intercepted by charges. So unless you have charges, then the electric field lines can go from any point to infinity. Okay, they do not break unless they meet charges. Okay, then these lines can never cross each other. Again, the clear logic of that is if two electric field lines were crossing each other at the point of intersection, you would have had two possible tangents, saying that here you can have two possible directions of electric field, which is not possible. At one point in space, the electric field can have only one direction, so this is wrong. This is not possible. And that is why two field lines can never cross each other. Okay. Next, electric field lines always emerge from positive charges and terminate at negative charges. And finally, the strength of electric fields is proportional to the area density of the field lines. Okay, so at any point in time, if you find the concentration of the field lines per unit area, then that is directly proportional to the electric field intensity. Okay. Next, these are some examples of the electric field lines. Okay, so here are electric field lines due to a positive charge, electric field lines due to a negative charge, electric field lines due to a dipole, and electric field lines due to two positive charges kept close to each other. Okay, so again, please remember this, that at any point, you realize you don't see two electric field lines crossing ever. That does not happen. Similarly, if you had to judge the direction of electric field, so here the electric field would have been in this direction. So you have arrows in these lines. So this arrow is representing that the field will be in this direction. Okay, so if the arrow was in the opposite direction, then the field would have been in the opposite direction. Okay. All right. Next, let's just quickly study about the electric fields due to various charge configurations. Okay, so electric field due to a single point mass. So you know, for a single point mass, you have, let's say, plus q. So at a distance r, at a point which is at a distance r, having a position vector of r. So here the electric field vector E vector would be k q over r square r cap. Okay, so please remember this. Otherwise, I can also rewrite this as k q over r cube times r vector. Now, in this expression, q is supposed to be put with proper signs always. Okay, use proper signs for the charge. Positive and negative will make a difference in the direction. Okay. Okay, so next you have electric field due to a line charge. Now please note that if this angle is alpha and this angle is beta, then the electric field here will have two components, right? It has one component like this and one component like this, EY and EX. In this case, EX is going to be lambda over 4 4 pi epsilon naught d, where d is this perpendicular distance to sine of alpha plus sine of beta, and EY is going to be cos of alpha cos. So these are the two components of the electric field of due to a line charge. Now, as a special case for an infinite line charge, in for infinite line charge, alpha equals beta equals 90. So you realize Ex is lambda over 2 pi epsilon naught d, y is 0. Okay, remember that. And this is very, very important. This is the electric field due to an infinite line charge. Very important result which we will be using a lot. Okay. Next, we'll talk about the electric field on the axis of a charged ring. So let's assume this charged ring has a total charge of Q and has a radius of A, and at a point on the axis which is at a distance x, the E vector turns out is AQX over x square plus a square to the power of 3 by 2 in I cap. And that these are the y-x axis. Again, this is a very important formula. Again, must remember. Okay, you will be using this also a lot. A lot of questions in IIT JEE have been asked related to this formula. Very important. Must remember. So this is also important. This you may not remember. That's still all right. But the one below for an infinite line charge, you must remember. Next, you have electric field due to an infinite sheet. So suppose you had an infinite conducting sheet. Okay, so non-conducting sheet for now with charge density sigma. An infinite single sheet to the E at any point would be again axis as y, x and z. So the E at any point would be vector would be sigma over 2 epsilon naught I cap. Okay, again put sigma with proper sign. Okay, for a non-conducting infinite sheet, this is at that non-conducting. Okay. Again, remember these formulae, very, very important. Next, let's try a couple of questions then. So here is a typical question that I think questions like this have been asked in JEE Mains and Advanced. Okay. So the first question says, a long wire with a uniform charge density lambda is bent in two configurations as shown in the figure. Determine the electric field intensity at the point O. So you have two situations here, and you are supposed to find the electric field intensity at a point at the point O. So how do you do this? I mean, you need to know the electric field intensity due to arc also. So for any arc, what is the electric field intensity? So I don't know if you remember how to calculate that. Now, try and remember it, try and solve this. Otherwise, I will show you how to go about this. Let's see. Let's see you guys give it a try and give me some answers. So, hint is that you can break this into three parts, okay? This into three parts. So, one, an infinite rod here, one, an infinite rod here, and third, quarter circular arc here. Find the individual e's due to all these, and I told you that E follows principle of superposition. So find the individual e's and then vectorially add them. Same thing here. Same thing here. You will break this into three parts. One this, one this, one this. Break it into three parts and try and find the answers. Okay. Again, this for semi-infinite one, you use the formula that I told you here and put alpha as 0 and beta as 90. Okay. Try and solve this. Hey, yaad kar lo. Mains people love asking questions like this. If you're preparing for your mains, you should know how to solve this. Okay. All right, let's see you guys give it a try. Again, uniform charge density of the wire is lambda. And the distance, the radius of the quarter circle and the semicircle is r. You have to find your answer in terms of lambda and r and epsilon naught. जल्दी जल्दी बता दो. This is one part. This is the second part. And let's say this is the third part. Anybody? आ रहा है आंसर? आप लोग कर भी रहे हो कि मेरी वेट कर रहे हो? So again, if you're trying the question, then you can let me know by writing trying in the chat so that I can wait for a bit. Otherwise, I'll go ahead and solve this. फिर बता दो भाई. Okay. So I'll wait for 1 more minute exactly, and in 1 more minute, if I don't have any answers, I'll solve this. Okay, भाई बहुत वेट कर लिया है. 1 मिनट और दे रहा हूँ. So if for anybody who's trying, and 1 मिनट बाद मैं खुद करके दिखा देता हूँ. Okay. So after 1 minute, I'll solve this. Okay. All right. So time up. So let's imagine. This is section 1 of the wire, section 2 of the wire, section 3 of the wire. So section 1 कैसा है? It is a semi-infinite wire. So semi-infinite wire would have created a field E1 X and something like this E1 Y. Similarly, this section 3 would have created a field like this E Y, and would have created something like this Ex. Now, due to the symmetry, you should remember for such a case, both the components will have exactly identical values. Okay, where is it? Yeah, right. Hmm. So if alpha is 90 and beta is 0, or alpha is 0 and beta is 90, you realize Ex equals Ey. Not for alpha equals 0, beta equals 90. You realize this Ex equals Ey, which is equal to lambda over 4 pi epsilon naught d. Right? Now, so because of this symmetry, what you realize is that these components will cancel each other out. हाँ, ये इसको cancel कर देगा, ये इसको cancel कर देगा. वही lambda भी same है, r भी same है. So both the components, any of these components would have had lambda over 4 pi r shall not as the magnitude. These four are cancelling each other out. So all I need to do is figure out the electric field due to that quarter circular arc. So for any circular arc, let's calculate in general. For any circular arc, okay, you have a circular arc. This circular arc tends an angle theta at the center. So you know by symmetry, the electric field, net electric field would be along this direction. Okay. So how to calculate that? You take at any point you take section of this ring. Let's say at some angle alpha, and let's say that this small section is extending an angle of d alpha here. So you realize because of this, the dE vector would have been like this. So what I can say is dE vector would have been equal to k d2 over r square. Okay. So now this dE vector would have had two components, correct? This dE vector would have had two components, one in this direction and another in this direction. Now you realize if I considered a portion which is symmetrically in the opposite side, then this would have also created a dE in this direction. Again, would have had this component and this component. So these components would have cancelled each other out. So can I say from here, E vector would be equal to integral of d cos alpha. हाँ, ये d है, ये अल्फा हो जाएगा. इसका जो cos alpha component है उसको इंटीग्रेट कर दूं तो नेट ही आ जाएगा. Okay, so let's do that. So I will say that this would be a into dq. dq can be written as lambda times r d alpha over r square into cos of alpha. ठीक है भाई. Now all you need to do is integrate this. Once you integrate this, the limits of alpha are going to be from minus theta by 2 to plus theta by 2. Okay, because theta was the total angle. So let's see what that gives you. That gives you k lambda over r times a sine of, you will get 2 times sine of theta by 2. So E vector is turns out to k by 2 pi epsilon naught r sine of theta. So for a quarter circle, theta is 90. Quarter circle theta equals 90. So E vector would be lambda over, and let's only write the magnitude because not specifying the direction. E would be lambda over 2 root 2 pi. That will be your answer. And I know by symmetry, the net E would be directed in this direction. This is the E vector's direction. Okay. right? Now let's talk about part B then. Part B also has three parts. Now we इसको भी हम तीन पार्ट में ब्रेक करेंगे. This being part 1, part 2, part 3. अब देखो 1 कैसा क्रिएट कर रहा है. 1 will create E1 X and E1 Y. Part B will create E3 X and E3 Y. And this quarter circle will create E dash, E due to 2. Correct? So from what I can see is that this part and this part are cancelling each other out, and the net E for part B would be simply E2 minus 2 times E1Y or E3Y. Both will be equal. Okay, part B. So E would be equal to E2 minus 2 times Y. Okay. What is E2? So for a semicircle, theta is now, how much is theta? Theta is now 180. So if I put in this equation theta as 180, what am I getting? Lambda over 2 pi epsilon naught r minus 2 times Ey. Ey was lambda over 4 pi epsilon naught r. So I'm getting 0. Okay, so that is a very, very interesting result. Here the electric field is 0. Okay. All right. Now let's try one more question then. Let us try one more question. This says a very long uniformly charged thread is placed along the axis of a uniformly charged ring as shown. The total charge on the ring is Q and the linear charge density on the thread is lambda. Find the force of interaction between the thread and the ring. I think if I remember correctly, this is a problem from Mirodov. This is a good advanced level problem. If I remember correctly. This one was in Mirodov. Okay, so why don't you guys give it a try? Let's see कितने लोग कर पाते हैं. तो जल्दी जल्दी ट्राई कर लो. यार ये देखो बड़ी बात है. You guys don't try too many problems. देख रहे हो सोते हुए बस. मुझसे नहीं करनी है मेहनत. भाई तुम्हारा क्विक रिव्यू है, तुमको प्रैक्टिस करनी है, तुमको कॉन्सेप्ट्स देखने हैं. तो मेक श्योर भाई जो लोग एटलीस्ट रिकॉर्डेड देख रहे हैं तो यहाँ पे जरूर ट्राई करेंगे ये प्रॉब्लम. डजंट मैटर सही आता है आंसर नहीं आता. सही नहीं आएगा तो सोल्यूशन तो दिख ही जाएगा. बट एक बार ट्राई तो करो. तुम्हें अपनी प्रैक्टिस करनी जरूरी है भाई. जेई से पहले मेरे को सॉल्व करते हुए देखते हुए कोई फायदा नहीं होगा. Yeah. I'll maybe wait for one more minute. Just wait for one more minute in case anybody is trying. कितने लोग देख रहे हैं? कितने लोग देख रहे हैं? कुछ बोल ही नहीं रहा चैट में, पता नहीं कर क्या रहे हैं. यूट्यूब पे लेक्चर खोल के इधर उधर कुछ कर रहे हैं पक्का. That is a problem with YouTube, you know? All right, so let's solve this. आपको पता है कि यहाँ पे किसी भी पॉइंट पे एक ऐसा ई आएगा और एक ऐसा ई आएगा. ठीक है. तो इसको ई परपेंडिकुलर कह देते हैं, इसको ई पैरेलल कह देते हैं. पैरेलल टू दिस लाइन. तो डायमेट्रिकली ऑपोजिट पे भी लोगे तो ऐसे ही आएगा. ई परपेंडिकुलर ई पैरेलल. So due to these fields, the forces will cancel. The net force would be due to this field. And I already know what E perpendicular is. E parallel is in fact lambda over 4 pi epsilon naught d. And d is r. Right? So that makes our life very, very easy. The net force F would be equal to simply lambda over 4 pi epsilon naught r into Q. That's it. Here's our answer. That is how easy this was. Okay. Next, we'll talk about electric flux quickly. So, what is electric flux? Electric flux is a measure of electric field lines crossing any area. Okay. So, electric flux is a measure of electric field or the number of field lines crossing a surface. Electric flux passing through any surface is defined as d phi is E dot ds. So, where ds vector is the area vector of any surface and E vector is the electric field at the location of ds. So, EDS cos theta. So, okay. Next, electric flux for a large surface, of course, can be calculated by integral of this. So, for any large surface, the electric flux is defined as integral of E dot ds. Okay, please remember that. Of course, since this is a dot product, this is a scalar quantity. So, let's talk about properties of electric flux. So, it's a scalar quantity. Now, it can be positive, negative, or zero. Why? Because of cos theta present there. So, this term, cos theta can be positive, can be negative, can be zero also. Okay, so that is why E dot ds can have any value. Okay, so fluxes can be positive, negative, everything. SI unit is definitely Newton per coulomb meter square or volt per meter. In two special cases, if at every point on the surface the magnitude of E is constant and perpendicular, then you have phi as E into S. Okay, this is only if E is constant and always perpendicular to the surface. So it always makes a zero angle with the surface area vector. Okay. Or if it is always tangential to the surface, then phi is always zero because at all times the angle will be 90. Next, you have Gauss's law. So I will quickly talk about Gauss law and then we will wrap up today's discussion. We will talk about applications of Gauss law tomorrow in the second part of the quick review of electrostatics. Okay. So in so Gauss law gives a relation between the net electric flux passing through a closed surface. Please note it tells you about the net electric flux passing through a closed surface with the charge enclosed by the surface. So whenever you have a closed surface means ये जो हो गया, this is an open surface. Okay, so here it is open. So this hand has a surface, but it is open. So the moment I close it, now this is a closed surface. Okay, you should not have any open ends in the surface. So whenever you have a closed surface, it will always bind a volume. There will be a volume inside this closed surface. So this law says that the net electric flux passing through any closed surface is equal to the net charge inside the volume bound by the closed surface divided by epsilon naught. Okay, so this is the mathematical form of Gauss theorem. Very, very important. This is in fact one of the fundamental equations that is a part of Maxwell's equations also. Okay, so very, very important. Now, closed surface over which the integral is carried out uh, is mostly an imaginary surface, and we call that Gaussian surface. Okay. Now, important points. So we'll just quickly talk about these important points, and then we will wrap up today's discussion. Okay. Important points about Gauss's law. So Gaussian surfaces are imaginary closed surfaces. Okay, they don't have to be real surfaces, so they can just cut through things. Okay, they can pass through different points. Flux through Gaussian surfaces is independent of the shape and position of the charges inside. Very, very important. So if you have a charge here, let's say plus Q. Now you can have various Gaussian surfaces. So let's assume you had a Gaussian surface like this, and you had another Gaussian surface like this. Okay, so you may have various kinds of Gaussian surfaces. Doesn't really matter. The flux through all these surfaces would be Q over epsilon naught only. So the shape of the Gaussian surface and the position of the charge does not really matter while calculating the net flux. Okay, it only depends on the net charge enclosed. Please note net charge. Now, electric field at the Gaussian surface in the integration is taken the net E due to all charges whether present inside or outside. So this is one thing about which a lot of students are confused. Okay, please don't be. तो सपोज आपके पास एक ऐसा चार्ज है यहाँ पर लेट्स से प्लस Q1 है और यहाँ पर एक प्लस Q2 है हाँ और आपने एक ऐसा Gaussian surface ले लिया तो you took a Gaussian surface like this. So when you're performing the integral of E dot ds, the E at any point, when you're considering the E at any point, so this E is due to both these charges. Is the net E due to Q1 and Q2 both. That is very, very important. A lot of people are confused about this. note E was net electric field due to all charges. Doesn't matter whether the charge is present inside the Gaussian surface or outside the Gaussian surface, as I have mentioned here. So please remember this. Next, we say that Gaussian surface can cut through a continuous charge distribution, but not through point charges. Again, very, very important. There is only one limitation while considering Gaussian surfaces, that your Gaussian surface cannot pass through a point charge. Very important. Again, if you want to understand the reason of that, you can watch my lecture, detailed lecture on electrostatics. There I've explained all these points, why this happens. But as of now, you just need to know this. So with that, let's bring our session for the day to an end. Yes. So this is where I will like to wrap up today's discussion. Okay, we will continue this discussion tomorrow. Don't worry about it. Before I take your leave, let me just quickly remind you, if you haven't gotten your plus subscriptions and if you're planning to, then these are the steps that you need to follow. You can go to the plus section of your app, select your goal as IIT and click on that get subscription button. Once you do that, you will be redirected to the payment page. So ARJ says, sir, can you show any other method of solving that principle of superposition of charges? मतलब भाई वेक्टर्स को वेक्टर सम से ही करना पड़ेगा ना, और तो कोई तरीका हो नहीं सकता। और तो कोई तरीका हो नहीं सकता। समझ में नहीं आया मुझे एग्जैक्टली क्या बोलना चाह रहे हो। Yeah, anyways, I was just about to end today's session. So what we'll do is, why don't you come for tomorrow's session, and tomorrow, if you can formulate your statement better, slightly better, then I'll be able to give you a more correct answer, right? So we will discuss your query tomorrow when, and you try and figure out what exactly is it that you are trying to ask. Just asking because vector sum confuses me. Okay, so there is no escaping that. There is no escaping that. You have to understand vector sum. Everything in 11th and 12th physics is about vectors. There is no escaping that. वर्क ऑन योर वेक्टर्स यार, इतनी बेसिक सी चीज है, उसको मत छोड़ो भाई, उससे उसमें कंफ्यूज रहोगे तो फिर बहुत दिक्कत होने वाली है. Anyways, so I was saying, when you're redirected to the payment page, you see a box which says, do you have a code? So there you can enter this code RD Live. This will give you a 10% off on all your subscription fees. Doesn't matter whether you choose plus subscription or the iconic subscription, for both you will get 10% off. And the fees of these subscriptions are as mentioned here, and you will also realize when you click on proceed to pay, you can choose from a lot of no-cost EMI options to break this amount also into very, very smaller amounts, so that you don't feel a pinch of the payment. Okay. Next, for those students who don't know what the iconic subscription is, let me just quickly tell you about that. The iconic subscription will take your IIT JEE preparation to the next level by allotting you personal coaches. So Unacademy, from the team of experts from Unacademy, you will be allotted personal coaches, and these personal coaches will personally mentor you and guide you throughout your IIT journey, and give you, apart from all your plus benefits, you also get benefits like you get to attend IIT workshops, receive expert guidelines from time to time, get study planners, and get test analysis sessions. Okay, so with all of these extra features, you will definitely power through your IIT journey. Next, students who have just entered class 11th and are worried, कि भाई क्या करना है अगले 2 साल, and how do I go about my studies? No need to worry. The Unacademy combo subscriptions are here. These are single one-step solution to all your study needs for the next 2 years. So these combo subscriptions take care of all your studies of class 11 CBSE, class 12 CBSE, your board exams, your IIT Advanced, your IIT Mains, everything covered in these combo subscriptions. There are 4 combos that you can choose from. The first combo offers you the iconic subscription for IIT JEE and plus for 11th and 12th. This combo starts at 4,600 a month. The second combo offers you the iconic for all 3, and this combo starts at 5,500 a month. Then you have a combo which offers you plus subscription for all 3, and this combo starts at 3,000 a month. Finally, you have a combo which offers you the plus subscription for IITJ and iconic for 11th and 12th, and this combo starts at 3,900 a month. You can choose a combo that suits your needs, and you would know better where you need to focus more. So choose a combo accordingly, and then you can leave all your study worries behind. Okay. Next, if you like today's session, do not forget to press that like button. ARJ, I can see you came To ask the question, you did not hit that like button. Not done. Okay. Don't be lazy. Just hit that like button and share it with as many people as you can. Okay, so that more and more students can benefit from this free quality content being provided to you through this channel. Like, share, and if you're new to the channel, don't forget to subscribe. Okay, don't forget to press the bell icon also, if in case you want to receive notifications of every session and lecture happening here on this channel. And the PDF of all the slides used in today's lecture will be available for download soon. So students who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link. So a lot of times students tell me that they have subscribed to the channel, they have clicked on that bell icon, they still do not receive notifications from YouTube timely. That ends up in them missing very important sessions. So make sure you're part of this Telegram group. That will make sure that you are always getting the timely notifications of all lessons and sessions happening here on this channel, and you don't miss out on any of the lectures. Okay. Okay, so that is where we will bring our session to the end. And before I finally leave you, let me remind you one last time, one code of many benefits. So remember this code RD Life. With this code, you can unlock the free features of Unacademy app. Here. Next, you also get 10% off on all subscription fees. And finally, you can enroll in various Unacademy events. Okay, so remember these benefits and using this code wherever you want to, wherever you want to avail these benefits. Okay. With that, let's bring our session for the day to an end. And as I said, we will carry forward this discussion tomorrow. So do join me back tomorrow for the rest of the discussion on electrostatics. And you guys till then keep practicing hard. Go through the session, practice some, and hello, Free Fire. Free Fire, you are a little late in joining. I was just about to end the session. Okay. Why don't you watch the recorded lecture and join me back tomorrow at 4:30 for part 2 of today's discussion. Okay. So, all right. So, I'll see you guys tomorrow then. Till then, you guys take care of yourselves. Keep practicing hard, keep studying hard, and take good care of yourselves. Bye bye.